Okay. What I said in this lecture, we are going to continue in the frequency domain analysis. And we said last lecture, we are going to have two type of, approaches for the stability and for the design based on the Nyquist, where the polar plot become the vehicle for that one. And then the other one is the body plots. So we are going to focus in this lecture on the body plot, while the polar, we will come to it a little bit later. So we have said many advantages in the, using the body plot, in the sense that, you will convert, okay, we will be using the 20 log of the magnitude, and that will help us in changing the multiplication of the factor into addition and subtraction, okay? So we will be moving in that direction, and we have said, if I have a general, transfer function where it has, constant term, poles and zeros at the origin, simple zeros or poles, and complex conjugates. And again, as I said, in the body plot, we said we are going to take 20 log of the function, which is going to convert all the, multiplication factor into, addition.
دكتور
تفضل.
معلش بس عندي سؤال. الملتيبليكيشن اللي في الدينومينيتور هذه تمثل ايش؟
It's poles and zeros. Yeah, and basically what we are saying, suppose I have g of s equal to, let's say, 5, okay, s plus 1, okay, s squared, s plus 3, s squared plus 2, let's say 7s plus 1, okay? Something over this format, this term, the regular term. Substitute for s, j omega. And that's basically what we have. Okay.
Okay.
But maybe the shape it look like strange, but we intentionally put it in this format. Basically, I would like to put a 1 in here, and then a factor with the frequency. This will help me. Okay, this will help in the approach where we are going to do straight line approximation. So if you are given a general transfer function, try to rewrite the transfer function in this way. Try to create one always in here. Okay, so it is the regular transfer function.
Yes, واضح دكتور.
Represent poles and the numerator zeros. Okay. And the the magnitude, the phase is going to be, we don't have to take the log of that one, because the phase automatically it will be the angle of the zeros minus minus the angle of the numerator, which is the zeros, minus the angle of the denominator, which are the poles. Okay, so basically, if we want to study, if we want to get the overall body plots, I will, since, as I said, this is addition, so let me take this term at the beginning. Okay, let me take those terms individually. Okay, this is the zero, this is the pole at the origin, and so on. And I will add them together. So basically, what we are saying in here, I will be addressing 4 factors. The first one is constant. The other one will be pole or zero at the origin, pole or simple pole or zero, and complex conjugates. Once I understand how do I sketch those various factors, then I can do the whole thing by adding their effects. Okay? Any question? So let me start.
Yes, Doctor.
تفضل.
تفضلك. بالنسبة الحين هو how can you ensure that this is the generalized form؟ يعني هو أول شيء بدأ بالfirst order, second order in this format.
Okay.
We can have, for example, third order, or this is maybe the.
Yeah. Okay. No. You could have a third order, fourth order, 10th order. Factorize them. You can factorize them.
I see.
If you have a polynomial, what you are telling me, suppose I have, okay, g of s equal to s4 plus 16s square cubed plus 15s plus, let's say, 15. Factorize what we are, I mean, the approach in here, which we are saying, we are assuming that the transfer function is given in a factorized form of either simple poles or complex, at most complex conjugate.
I see.
Okay, so convert them if they are not in that form. For example, Abdurrahman, suppose a simpler one, 1 over, let's say, s cubed plus 2s squared.
Yeah, this can be written. But
S
مثلا
is going to be s plus 1, s plus 2, sorry.
yes. If we have, for example, 1 over s cubed plus s plus 1.
Okay, factorize them. Get, you have to the approach.
Yeah, we have to factorize. Yeah.
Yes, the approach is based on the factorized form. Okay, so let me start with the constant. If I have a constant, okay, then 20 log of the constant will be what? It's going to be set a constant. So if I want to sketch it, if this is log omega, and this is the 20 log of k, so it's going to be constant. If k is positive and the angle is going to be 0 angle, this is, let's say, this is the phase, is going to be 0 angle, isn't it? What will happen if k is negative? If k is negative,
Cannot be.
كيف؟
Cannot be لأنه اللوج مشكلة. لوج نيجاتيف يعني ولا
ليش مشكلة؟ وين المشكلة؟
Theta will be minus.
Okay, g of s equal minus 20 or minus 20. Yeah. ايش المشكلة؟
أنا حسبت تقول الكي نيجاتيف. الكي نيجاتيف.
Yeah, this is k negative. So take the magnitude. What's the magnitude?
20.
20. Where will be the problem? The angle. If k is positive, so you just take the 20 log of the of k. K in this case 20. Take the log of 20 and multiply by 20 dB. So this is basically what we'll have, and the angle will be 0. If k is negative, this is minus 20. The magnitude will be the same. The problem will be with the angle, are compensated by the angle, which is 180. Okay. Now, let's move to the, suppose I have a pole at the origin. That's basically I have g of s equal 1 over s, which is g of j omega equal 1 over j omega. Take 20 log of that one. So it's going to be, this in denominator, put it in the numerator, it's going to be minus 20 log omega. And the angle is going to be minus 90. Do you agree? Tangent of omega over 0. Okay. If it is 0, then this is going to be infinity, which means tan inverse of infinity, which is going to be 90. Since the denominator is going to be minus 90. So if I want to sketch it in semi-log graph paper, this is log omega. And this is 20 log of omega. Okay. what does this relation represent? I'm using the logarithmic scale. So basically what I'm saying, let me take this as my, let's assume this is x. So y equal to minus 20x. So what do I have? I will have a straight line with a slope of minus 20. Any question here? Because my scale is log 20. That's why I'm doing the semi-log graph paper.
For the case, what that we have addressed is the case of having a constant g of s, right? G of s was a constant.
If you have constant, you would treat the constant alone and treat this one alone. Add them.
يعني من شوي احنا we assume that the g of s is equal to k. In the
Yes.
case of
Okay. Now it is gs equal 1 over. Look, Abdurrahman, what I'm saying, I'm taking those factors. I'm sketching this one by itself. I'm trying to sketch this one by itself. Now, at this stage, this is what I'm doing in here. I'm taking this one.
جميل. Well,
This one, I'll do this one, and I'll do this one. Okay. I understand each one alone, put them together to get the overall picture. So I'm taking one factor at a time. Okay. I hope that's clear. What I'm trying.
yes. Now it's clear.
Okay. So now, as I said, this is going to be straight line, but we have to be careful here. Where do I start? We said, if you remember, we cannot start our origin at 0 because log 0 is infinity. So suppose I have 0.1 here and I have this system. What will be the value of 20 log at 0.1?
Minus 2.
Any other thought?
Can you repeat, Doctor?
What I'm saying, if my origin is at 0.1, start at 0.1. If I substitute 0.1 here, what will be the magnitude? Okay, first of all, log of 0.1 equal to what?
عفوا دكتور الحين 0.1 هي كلها اللوج صح؟ لوج اوميجا كلها 0.1.
لا. Omega equal to 0.1.
اي لانه انت حاط في الاكس لوج اوميجا عشان كذا انا خربطت.
لا, okay. I want to, if you want to have it linear, you must assume log 10 omega equal to x. But if I want to evaluate, I'm evaluating.
يس لانه لو تلاحظ هنا في الاكس حاط لوج اوميجا.
كيف؟
في السكتش هنا انت حاط في الاكس لوج اوميجا دكتور.
لا. Look, this is log omega. What I'm saying, forget about my graph. Okay, I need 20 log base 10 of 1 over j omega to 0.1. Can you tell me, evaluate this? Can you give this value?
Yes. Now it's
20.
Okay. So
minus
20, yes.
20 dB.
minus 20, and I have minus here, so it will be 20. How about if I have this 1 decade later, which is 1? What will be the log of this quantity at 1?
0.
0. So, look, I will have, and the slope is in here, minus 20 dB per decade. As I said, it's important, where is my scale? Suppose I start by 0.01, and this is 0.1, and this is 1. What will be the 20 log of the magnitude?
Minus 40.
It's going to be 40.
40.
Okay, it's going to be 40, and then it's going to be at 1 equal to 0, so this is basically what we have. So we have to be careful. What I'm trying to say, the start of the curve is going to be important, depend on where do you use your scale. Okay. Now, what will happen if I have a, if I have a zero, not a pole? What do you think? What will happen? How does
It will be increasing.
what?
It will be increasing.
It will be positive. Exactly. This is negative minus 20. If I have a zero, it will be the other direction. It's going to be 20 dB. Now, suppose I have not one zero, not one pole, two poles. What will happen to the slope?
We add them.
Which is going to be, what will be? If I have two, each one contribute minus 20, so two will contribute minus 40. That's basically if I have n of them, I multiply by n. The 20 multiplied by n. So if I want to graph them, of course, the angle is going to be, okay, the angle is going to be multiplied, minus 90 multiplied by the number of poles which I have. This is the zero. So this is basically what I'm trying to say. Look, what do I have in here? Suppose I have one pole, and this is my scale at 0.1. I will go on the red line. If I have two poles, I'll start by 40, and my slope is going to be minus 40 dB per decade. If I have a zero, it's going to be a positive slope of 20. Two zeros, positive slope of 40 dB. The corresponding phase, if I have one pole, I have minus 90. If I have two poles, I'm going to have minus 180. 10, 90, two zeros be 180. So if I have a simple, if I have a pole or a zero at the origin, I can address it in this way. Any question?
الانجل يا دكتور بس معليش لو توضحها الحين.
Okay.
يكون عندنا
We said, suppose I have g of j omega equal 1 over j omega. This is 1. So the angle is going to be what? In this case, tan inverse.
Yeah, tan inverse.
Of minus, okay, is going to what? It's going to be since this is going to be what? Omega over 0, and it's in the denominator, so I put minus.
Yes.
To be okay. This is infinity. It's going to be what? It's going to be minus 90. If I have one, suppose I have two, g of j omega equal to 1 over j omega times 1 over j omega. The contribution of each one will be what? The contribution of each angle is 90. And
Then you add them.
Okay?
And then you add them.
You add them.
Yes.
You add them. Okay? So if you have two poles, it's going to be minus 180. If you have three, so you basically, if I have 1 over j omega to power n,
n multiplied by minus 90.
Okay, and that's basically what we have. And it's straight lines.
J is not in the bore عندك.
If
J مو داخلة في البور.
ما فهمتك.
It is J times omega n or all J omega n?
No, you take, no, well, if suppose you have, okay, what I'm saying in here, suppose I have a complex number. Suppose I have W equal to A plus JB. What will be the angle? The magnitude will be what? The magnitude will be A squared plus B squared. Do you agree? How about the phase? Tan inverse of the imaginary over the real. In this case, okay, the imaginary, the coefficient will be omega and the real equal to 0. You don't take the J, you take only the associated number with it.
Yes, yes.
Okay. Now, suppose I have a simple pole. I have simple pole. G of J omega equal 1 over J omega plus, okay, 1 over J omega tau plus 1. So the magnitude, what will be the magnitude? Can you tell me? What's the magnitude in here?
Well, it's 1 over omega.
The magnitude is going to be
squared
1 over root of
over,
omega tau squared
plus 1.
1. Okay. Well, I'm taking 20 log of this quantity, so I can take this one in the numerator. If I take to the numerator, what do? It's going to be negative. And let me take the negative out. And I'm taking, I don't use, well, rather than, so this is equal to minus 20 log
So minus 10 يعني.
to the half, okay, omega tau square plus 1. Take the half out,
Yes.
and that will be minus 10. Okay? Now, suppose this is where the beauty in here, that's why we are putting 1 in here. Look, if omega tau much greater than 1, what will be the magnitude approximately equal to what?
Omega tau.
Oh, if omega tau, sorry, let me take the case the other way around. If omega tau is much smaller than 1,
0.
صار زيرو.
so this is, in this case, the 20 log approximately equal to 0. If omega tau now greater than 1, so 20 log 10 of the magnitude equal to, I will ignore this case and take the square out, so it's going to be
Minus 20
log, okay, omega tau. Okay. Well, of course, at omega equal to tau, at omega equal 1 over tau, this will be 1, which will be 0. So basically what we are saying in here, if I modify my scale, this is log omega tau as a matter of fact, okay. It will be up to this point. This is, let's say this is 1 over tau. The magnitude will be 0, and then the magnitude is going, it's going to be this. It's going to be minus 20 dB per decade. And this point we call the corner frequency or the break frequency, which is location of the pole of the system. Of course, I can get the exact value at omega n, at omega equal to 1 over tau from here. What will be the exact value at omega equal 1 over tau?
0.
No?
1.
If omega equal 1 over tau.
log root log 2.
Log, okay. Log.
Exact value, yes.
Yeah, exactly. That's what I'm saying. I need the exact value. I want to modify. This is my approximation. I can modify my approximation. At the
Minus 3 dB.
Is it going to be the 3 dB? It's going to be the minus 3 dB point. So if I want the exact, so basically I will have something like this. Okay. So what we are doing in here, we are doing an approximation, straight line approximation. Okay, we are doing a straight line approximation. Let's go to the phase. How about the phase? The phase is from here. Okay, in the phase, we can, I mean, the phase to start with, it's simple. You can just, you know, the phase, basically, what you could do in here, you can sketch it exactly because you know substitute and get the. But what we would like also to do an approximation. Okay, and this is basically look. This is what I'm saying. The approximation here. Okay, if I locate the corner frequency, which is the pole of the system, and take the positive side. Okay, so it will be 0 before the corner frequency, and it's going to be minus 20 dB per decade after the corner frequency. If I want to do the approximation for the phase, it is a little bit more complicated. What we will do, our approximation, it will be 0. Okay, if this is the corner frequency, it will be 0 before a decade, 1 decade before the corner frequency. And it will be 90, 1 decade after the corner frequency. And then just connect between them. At the corner frequency, if this is at the corner frequency, what will be remember, the phase is tan inverse of omega tau. At the corner frequency, at omega equal to 1 over tau, what will be the phase?
Minus 45, yes.
45.
Minus 45, yeah. So now tell me, if I want to do a straight line approximation, which is this is the red one, what will be the slope? This is 0 and this is 90 in here. 0 to minus 90. And I'm moving 2 decades. What will be the slope? What will be the slope, Shabab? You are going 2 decades and moving from 0 to minus 90. What will be the slope?
سؤال يا دكتور، الحين اسلوب حق الفيز تبعه ولا كيف؟
كيف؟
اسلوب للفيز ولا اسلوب للماتيود؟
No, we are talking now. I'm talking about the phase. The slow, the amplitude. Okay, the approximation. Basically, you locate your corner frequency. Okay, just go before the corner frequency, it will be 0. After the corner frequency is going to be minus 20 dB per decade. This is easy. What I'm saying, in the phase, you can do the linear approximation, but it will be a little bit complicated because in here, I locate the corner frequency. I'll go 1 decade before, 0. 1 decade after will be 90, and I just connect by minus 45 dB, minus 45 degree per decade. Okay? Any question?
So we approximate the phase by a straight line.
Yes. The red one is straight line. But the problem is because I'm, going into the 1 decade before, 1 decade after, when you have many factors, it becomes a little bit messy. We are going to see it in a moment.
Yes. طيب يا دكتور، الحين بالنسبة للماgnitude, we have these kind of approximation. Do we need to alter the 1 over 1 plus j omega tau to reach the approximated curve, or we will just draw or sketch the exact curve and then
look.
from the sketch
We have taken so far gain, simple gain, pole at the origin, pole or 0 at the origin, simple pole or 0. This is for the pole. Of course, for the 0, what will happen? What will happen if I have 0 rather than pole? What do you think? What will happen?
So
Be the slope.
it will be a positive angle and the
Exactly. This is what will happen.
everything. Yes.
Now, let's take an example in which I have all those factors, and let's see how do they interact with each other.
Add them together.
Okay. So suppose I have this system. Sketch the body plot.
We approximate Dr. J omega plus 10 to J omega plus 1, and then you can.
No. Look, okay. Sketch the body plot for the system.
Just for the sake of simplifying the problem.
First thing we will do, we try to create ones. Okay. The format, the same format which we use. So I will have 5,000. I need one here. So multiply by 10, and that will give me what? J omega over 10 plus 1. Any problem here? And in the denominator, I will have the first one, J omega plus 1. It's already in the given format. The other one is going to be J omega over 500 plus 1. And this is going to be 500. So if you simplify it, it's going to be 100 J omega over 10 plus 1. Okay, J omega plus 1 and J omega over 500 plus 1. What are the corner frequencies now? Which are the pole of the system?
دكتور مو 10
KF,
KB is equal to 10.
corner frequency. For the 0, I have at what? What the value? What's the corner frequency at?
Ten.
10. Poles,
1 and 500.
exactly. This is what we have. Okay. So the corner frequency are the location of the poles and the zeros. So I have it in the format which I want. Let me start sketching one at a time. Okay, let me assume this is my 0. Let me start with the magnitude. Okay, 20 log of, or the D in dB. And this is, my scale, suppose this is 0.1. So let me take, first of all, I have the constant, which is 100. Okay, so what's 20 log 100? Log 100 equal to what?
To 2.
2 multiplied by 20. So this is
40.
40. And it's going to be,
So this is for the first 0, yes.
okay, this is for the constant. Now, what's the first corner frequency?
We have for the 0, we have 10.
No, but for the pole, we take
Pole,
the
we have 1.
1.
Will be 1.
So it's going to be 0. Okay, it's going to be 0 until 1. And this is the 1. And then it's going to have minus, it will continue with me, minus 20 dB per decade. I have another corner frequency at 10, as you said. And so up to 10, this is 10. This is 100.
بس يطلع فوق. أبو 10 هذا يطلع فوق 10.
So this one is going to be positive. So it will be 0
Up to 10.
and it will continue.
بس دكتور الحين to continue هذا يعني الاسلوب هذا لازم يترسم بشكل دقيق صح يعني it has to go
Well, you just sketch.
after 10.
It will go to infinity.
I see, but the slope of this curve.
Yes, it's 20 dB per decade.
Mm-hmm.
Now the last one, 500. So if this is the 100, 1, 2, 3, 4, and 5. It will be 0, and then it will have, so at 5,000, okay, 1, 2, 3, in here, and it will continue. So let's focus on the, later on we'll come and address the phase. Now, all what you have to do, okay, add them. Let's add them. So let's go between 0.1 and 1. What is the overall of everything?
السؤال بس معلش يا دكتور.
It will be what?
40.
40. Now, between 1 and 10. So the 40 and
40 minus the slope.
so it's going to be this line, isn't it?
Yes.
Yes.
At 10, what will happen? I have
Will be
a positive slope.
will be 20.
It will be,
The contribution. Yes.
Constant.
it cancels, so it will be constant until where? Until the 500.
500.
So I will move in this line. Then after 500, okay, what is the overall slope of the system?
20 dB per decade
It's going to be what? Exactly, look,
minus
minus 20. Because look, I have minus 20 and then plus 20, that cancel becomes 0. Now I have minus 20 from here and on, and it will continue this way. So this is basically what I'm saying. Constant, then it becomes until 10 is going to be negative, then it will be constant again until 500, and it will be negative. Is this clear? So I'm just adding the term.
دكتور السلوب حدناه من ال 100 صح؟ احنا اخذنا 220 log 1 over 100 هذا اللي يعطيني السلوب.
No. This will be constant. No. The slope will come from the poles and zeros, not from the constant doesn't give you anything.
كيف عرفنا انه minus 20 decibel per decade؟
Okay, no. Look, what I'm saying, okay, this is also, you can think about as a rule, and you should know whether you are, your approach is, you should always have a roadmap. Before you start even, you are starting with a constant. You can determine what is the final slope. The final slope is the difference between the number of poles and zeros. Because look, each zero will contribute 20 positive. Each pole will contribute a 20 negative. Take the difference between them, multiply by 20, and that will determine the final slope. Is this clear? Final slope equal 20 times number of mixed minus poles, because always the poles minus number of zeros. Okay? So in advance, ahead of time, you know what will be the final term which we are going to reach. Okay? Any question here before we go to the pole, to the phase? The phase is a little bit more complicated in the approximation. Any question before we go to the phase? Let me clear and let me start with the phase. Okay. Now for the phase, what do I have? Okay, let me assume this is my again. The phase. Suppose this is 0. This is minus 90. This is, let's say, minus 180. And this is 90. Okay, what will be the contribution of the first one? What will be the contribution of the constant and the angle?
0 degree.
0. I don't have anything. Now, let me start with the first corner frequency at 1. So I have corner frequency, look, at 1, at 10, and at 500. Isn't it? So now we said the approximation, okay, I will have this is 0.1, 1 decade before the corner frequency, the angle will be 0. 1 decade after, which is the 10, the angle will be 90. And this is going to be minus 45 degree. How about then I have at the 10. So this is the 10. 1 decade, which is this one, 0. 1 decade after, which is the 100. Okay, 90. Sorry, this is the 0. No, this is the 0. And 100, it will be 90, and connect. We said, okay, from here, connect. This is 45. Then the 500. This is the 500. And it's pole. So 1 decade, it means that I should be at, if 1 decade before the 500 will be where?
50.
50. So at 50, it will be 0. Then 1 decade after, at 5,000, it will be minus 90. And then you connect. Now, the interval, they are, more interval we have to worry about. But the thing is, just add them. Add those curves. If you add them, this is basically what you will get. Again, you can tell what will be the final angle will be. What will be the final angle in this case? Tell me.
Minus 90.
Minus 90, because you have 1 angle in the numerator, 2 angle in the denominator. Okay, each angle will contribute when omega go to infinity is 90 degree. So difference between them will be minus 90. And this is the curve. But as I said, in the phase, it's a little bit messier. And if you want it exactly, use MATLAB. In MATLAB, you don't have to worry about any factorization. Just give the numerator, denominator, and then it will give you just the body. And this is basically what we'll have. Well, the red curve is the approximation. The blue one is the exact. But look, in the straight line approximation is, very reasonably, approximating the exact curve. Okay. Okay, Shabab. Any question? Any question? Let's take the case of the complex conjugate. Okay, the complex conjugate, suppose I have G of S equal to
دكتور
أيوة
بالنسبة للفيز approximation مو قريب صح؟
كيف؟
الفيز approximation مو قريب.
الفيز approximation فيه
قريب للأكشول أو مو قريب؟
لا الفيز look this is what we have done. الفيز الحقيقة يعني it's very complicated as you can see. يعني الكيرف هذا بالشكل هذا no matter what you do بالapproximation you will be way من يعني الابروكسيميشن ما يكون بالدقة حق الماجنتيود because of التداخلات هذه اللي هنا. what we have seen. So usually the magnitude curve approximation is better. In the design, however, look, when we go to the design, and now we have MATLAB available to us, so usually we will get the exact both phase and gain. We use the exact because in there we need certain quantities. We call it phase margin, gain margin, and we want to position our our compensator at certain place. So we need the precision should be very high. That's why we will go to the exact curve. But for the approximation, this is basically what we will be using. Okay. This is clear.
Great. Yes.
Okay. Now suppose I have a square plus 2 zeta omega n s second order system plus omega n square. I want to show you where this term came from. So g of j omega equal to omega n square. This is going to be j omega square plus 2 zeta omega n j omega plus omega n square. Let me factorize the omega n out. So I will have 1 here, and let me put this one here. So it's going to be 1 for this one. I'm dividing by omega n square plus j 2 zeta omega over omega n plus, okay, j omega over omega n the whole thing square. This is basically this term, the upper term came from. Okay, now let me get the magnitude. What will be the magnitude of the, if I have g of j omega equal to 1 over 1 plus 2 zeta omega n, sorry, omega over omega n plus here j plus j omega over omega n. What will be the magnitude? How do I get the magnitude? First of all, what is this going to be?
So minus omega square over omega n square.
So let me put the real together and the imaginary together. So I will have 1 over 1 minus omega over omega n square plus j 2 zeta omega over omega n. This is what I have. So the magnitude is going to be, if I take the magnitude only, it's going to be 1 over square root of 1 minus omega over omega n square plus 4 zeta omega over omega n square. Do you agree? This is the magnitude. If you take 20 log of the magnitude, just take 20 log magnitude. So let me put it in a neat form. This is what we are going to have. And the angle, this is going to be the angle. Take the, okay, the imaginary over the real. Tan inverse of the imaginary over the real. Any question here? Now, look. Let me suppose I have omega over omega n much smaller than 1. What do we have in here? What is this going to be compared to the 1?
So the 0.
So I will ignore it. So I have 1. And this is, since it's going to multiply by zeta, zeta is a very small number usually. So it's even smaller. So the overall thing will be what? 20 log magnitude equal to 0 if omega over omega n much smaller than 1. take omega over omega n much greater than 1. Log, of course. Okay? What does that equal to in this case? This one with this one will be what?
We need to simplify يعني. شيل
It
1
must be omega n to the power 4
Yes.
or omega n to the power 4. Do you agree? The one will be dropped. The one will be dropped. Shabab, if you can give me 1 second, I will, 1 minute. I will repeat this one next time, inshallah. But basically, this will go, and this will be smaller than this one. So this basically, it will be minus 40 dB per decade, if this condition is correct. So basically, if you have complex conjugate, think about it. You have two simple poles at omega n. We will stop in here and we will pick this next time. And I will go through it again.
عندي سؤال بالله في شو اسمه